Welcome. This is section 12.3, which is differential equations. Now you might be thinking, Miss, we are doing antiderivatives. How come you go back to differential equations? So in this section, I will be integrating and differentiating, which is we both will be integrating and differentiating. So usually we use in this section, we look at exponential growth. And you probably have seen this when you're trying to find the compound interest when you're compounding continuously. So you have A is equal to P e to the power RT. That means this is growing exponentially. So this is the same principle here. I have Q is equal to Q naught e to the power RT, where Q is quantity of time and Q0 is that Q when time t is 0, R is the rate, and T is the time. So in this particular section, we'll be looking at exponential growth and probably exponential decay. We'll see. So let's go ahead and take a look at the first problem here. It says, find the general solution for the differential equation. Okay, so here I have dy by dx. So they're asking me, hey, I gave you dy by dx. Give me what y is. So if my y was here, they already differentiated with respect to x and they got 6 over x. Now they're asking me to go backward. To do that, what I will do is I'll go ahead and write down dy by dx is equal to 6 over x. And I'm going to cross multiply. So here I want you to see what's happening. My dy is equal to 6 over x times dx. And now, remember, I'm trying to get back to y. They differentiated it. To go backward, I have to find the integral. And if I don't see anything here, you know there's a handy-dandy 1. So here I have integral of 1 dy is equal to 6 integral of 1 over x dx. So now integral of 1 is y. 6 integral of 1 over x is ln absolute value of x plus c. So all you're doing is you're working your way backward. Now go ahead, find the differential of this one. You will get back to the same function. All right, let's go ahead and see the next one. In the particular solution of differential equations, they said, hey, find me the value of y, okay? So here, let me go ahead and write this down. I have dy by dx is equal to, what do I have? Negative 9 x power 8 e to the power negative x to the power 9. I'm going to come back to this part in a minute. This is what I have, and they're asking me, hey, what's y here? So they differentiated it. To get back to y, I have to find the integral. So I'm going to take the dx and cross multiply, and you're going to see in a minute y. So I have dy is equal to negative 9 x to the power 8 e to the power negative x to the power 9 dx. And you know what I have to do? I have to simply find the integral. I'm not going to put a 1 all the time, but you know there is a 1 here. So 1 integral of 1 dy is equal to, if you've done 12.2, if this is my function, I'm going to use a different color here. So you can see if I have my f of x is equal to negative x to the 9, my differentiation is going to be negative 9x power 8 from the previous section. So here I have my differentiation and here I have my function. So the integral here is simply going to be different color, e to the power negative x to the power 9 plus c. And here the integral of 1 is y is equal to e to the power negative x to the power 9 plus c. And this is from the previous section, which is right here. The formula is right here. So if you have not done this section, what we are doing right now is not going to make any sense to you. Okay, once it's done, I cannot have a c here. Now I'm going to go back and use what they gave me. They said y0 is equal to 2. What they mean is when my x is 0, my y is 2. I'm going to go ahead and plug in. I'm going to plug in my y as 2, plug in my x as negative 0 power 9 plus c. Anything to the power 0 is 1 plus c, so my c is equal to 1. So my final equation, I'm going to write that in blue, which is y is equal to e to the power negative x to the power 9 plus 1. And if you want, you can always, which I encourage you to, find the differentiation of this so you can get back to the previous function. All right, so technically they're telling you, hey, I differentiated it, you integrate and give me the value of y. All right, now, oh, they did match, of course, I forgot to check. Now let's go ahead and see this question. In this question, they're asking us, is y is equal to 25x a solution of this differential equation dy dx is equal to y over x? Your textbook has kind of different way of expressing it, but this is what I'm going to do. Y is equal to 25x on this side, and here I'm going to write dy by dx is equal to y over x. Okay, now let me differentiate this one. When I differentiate, I'm differentiating on my left hand side. When I differentiate, what do I get? I get dy by dx is equal to 25 because derivative of x is 1. Now I see that dy by dx is 25, and here I have dy by dx is y over x. Then that's not equal. But wait a minute. I can go ahead and change my y. What is my y? My y is 25x. So I'm going to replace my y with 25x divided by x. X and x cancel. And if you look closely, dy by dx is 25 here, dy by dx is 25 here. So they are the same. Okay? All right. Now, find the general or particular solution as indicated in the following equation. Again, I'm going to come back to this later, but first I'm going to deal with this one. This question is slightly tricky, so I want you to pay attention here. So I have dy by dx is equal to negative 0.3y. If I did not have the y here, let me go back to this. If everything was in terms of x, like in this case, I have no problem because I'm differentiating with respect to x. But because of this y, I will have a couple of steps extra, but not to worry. Let's see what to do. I'm going to bring all the x's to one side. So I have dy is equal to negative 0.3 y dx. And now I'm going to bring the y to the other side, so I'm going to divide both sides with y. And when I divide both sides with y, I have 1 over y dy is equal to negative 0.3 dx. I can write dy over y, or I can write 1 over y times dy. You're going to see that in a minute because it's related to the formula. And now, to get back to y, what do? Integral, integral. So here, 1 over y, remember, integral of 1 over x is ln x plus c with the absolute value. So integral of 1 over y is ln absolute value of y plus c because I'm differentiating with respect to y. Now here, integral of negative 0.3 dx. Remember, if I don't have anything, there's always a 1. So this is negative 0.3, and integral of 1 is x. Because, you know what, let me put a constant. Let me put that back. Plus a constant c here. Okay? Now the constant c has to be on this side because I need to get y by itself. All right. Now once this is done, my y is still not by itself. There is ln y. As soon as I see a ln, how do I change from ln to not ln? The only way you can change logs to the numbers without logs is simply raising them to the base. So ln is base e. I'm going to raise this whole thing to the base e. So now this, you can go ahead and plug into your calculator. E to the power ln x is x. So e to the power ln y is y. Again, this is logs from algebra. And this is nothing but e to the power negative 0.3x times e to the power c. Remember, when I add the powers, that means I'm multiplying the bases. It's like x power 2 plus 3 is x power 2 times x3, because when you multiply, you add your bases. Okay, so now, if you look closely, this is also a constant. So I'm going to go ahead and I'm going to make this a whole constant. I'm just going to use a different color here. So this whole constant is now a purple C. You're going to see why. And now, am I done? No, you're not, because you still have that constant there. So now I'm going to go back and use this second information that they gave me. Here they're telling me, hey, when your x is 0, your y is 50. Very good. Thank you for that. I'm going to go ahead and plug in. My y is 50, e negative 0.3, x is 0 times c. Anything to the power 0 becomes a 1. So 50 is equal to c. Now I'm going to go ahead and plug in my c. So I have y is equal to, instead of c, I'm going to plug in 50 e to the power negative 0.3x. And that is your final answer. So you will not give the equations in terms of c. You will use the extra information that they gave you to find the value of c. Okay? Here, the tricky part was to bring all the y's to one side. And as soon as you know that, boom, you have your answer. So always look if there's y's on both sides or y on one side. All right, now let's go ahead and take a look at this problem. For a person learning to type, the number n of words per minute that the person could type after t hours for practice was given by limited growth function. So that's an exponential function. Oh, there you go. Yes. What is the rate of improvement after 15 hours of practice and 40 hours of practice? I'm going to zoom in. The moment they say rate, you know you're differentiating. Going all the way back to chapter 11. So here I'm differentiating. Rate is with respect to time. So n prime, you know what? Let me go ahead and distribute the 100 first, so you can see. Now I'm going to differentiate this one. What I'm also going to do is, because I don't have enough space, I'm going to move this to this side. And now let's differentiate it. I'm going to use a different color. Which color should I use? Let's say, or no, orange is going to be too bright for you. So here, n prime, differentiation of 100 is 0 minus 100 is a constant. E to the power negative 0 t is e to the power negative 0.01 t, and differentiation of 0.01 t is negative 0.01 t. So here, when I finally multiply all of this, you can use your calculators for this one. I have my n prime is equal to, this is negative 100 times 1 is positive 1. So this times this gives me positive, excuse me, here there should not be a t, because the derivative of 0.01 t is simply 0.01. It's like finding the derivative of 2x, which is simply 2, not the x. So I made a mistake there. And now this is negative 0.01 t, because this, where's my highlighter? This times this gives me 1, negative times negative gives me a positive, and this stays. So my n prime, so my rate is negative e.0, negative, my n prime is e to the power negative 0.01 t. Now what they're asking me is, what is the rate of improvement after 15 hours? Okay, this is negative 0. E to the power 0.01 times 15, and that should give you 0.86. Now they're asking me what's the rate after 40 hours. That is e to the power negative 0.01 times 40. That should give you 0.67. And again, if you have questions, or you should always start with reading your textbook first, looking at the PowerPoints, examples, the videos, and then use this as your resource. Hope this helps.